In this video, I want to look at the basics of Java statements, expressions, and variables. We want to be able to learn about variables and what are called the types of variables, and recognize what makes an expression and a statement in Java. So let's think about making some sort of small program that actually does something. We might want to make a calculator for going to a restaurant and figuring out what a tip or gratuity should be. And you should recall that a tip is usually a percentage of the overall cost. So if your bill is $50, you're going to say, I'm going to leave a tip that's like 10% of the bill or 20% of the bill. When you're working on this kind of problem, it is important to think about how would you do it yourself. You can't write a program to solve something that you don't know how to solve yourself. Maybe you don't know how to do it 1,000 times or do it for 1,000,000 pieces of data, but you have to know how to basically do it on your own. Otherwise, you can't encode the process in a program. So, for example, if we have a bill of $65.38 and a tip percentage of 18%, we have the original amount, and we multiply it by that tip percent, and then divide it by 100 to turn it into a fraction, right? We don't want to make it 65 times 18. We want to make it 65 times 0.18 to get the tip amount. So again, you have to kind of understand how the math that you're working on actually is supposed to happen. So we could actually write a little piece of code that does that calculation for us and gives the answer. And we're going to do it all in sort of one place. So we have our print line statement that's going to output some information to the console. And I'm going to put in a math expression in here to do the calculation. So I'm going to say 65 point, whoa, what are you doing now? 3, 8, looks like I changed the number somewhere along there, 3835 times 18.0 divided by 100.0. So we'll talk more about this obviously, but I'm just going to run it, see what it does. So I got a tip of $11, and of course I didn't really understand the difference between money, where you only have pennies, and just normal math. So we have too many decimal places here, and that's that's fine for now, right? So these text representation of numbers I have here have a specific meaning in Java. They're called literals. They're written out in the program. They can't really be modified except by changing the program itself. And this idea of literals shows up a lot when we had our system out print line hello. That hello was also a literal of text, right? And it's the quotes there that made the difference, that made us realize that was text of some kind. So they're really unchanging representations in a program. Now, when I first figured this out, I sort of wrote out something saying my tip is equal to this expression here. And what is this tip word? Well, in math, like algebra, and in real life and programming, we often use words to stand in for some actual value. And when you look at that word tip, it really means the value of what that tip was calculated to be. And this kind of word is what we call a variable, and we can use that in Java as well. So a variable is basically just a named value that is stored in the computer's memory. And so rather than just saying 1,000 all the time, you might say, cost of construction is a variable or something like that. And that way people that read it understand what it is. To use a variable, and we'll go in a lot more detail about this, but basically there's a basic structure. You have to declare it to be a certain type. A double holds numbers with a fractional part. You give the type, you give the name, and you give an equal sign that says assign this value to this place, this location here, this name. Now Java has a lot of data types. You can make int variables, so int count equals 1. An int holds a number without a fractional part, so like -1, 10. So I'm not allowed to store something like 1.5 in an int variable. I can have a double, which we looked at. Double GPA equals 3.999. I wish, right? A double holds a number with a fractional part to it. There's different versions of these as well. You can have a byte, which holds a smaller range of values, and we'll talk about this more. There's also a short or a long, and along with a double, there's also a type called a float that can hold fewer decimal parts. Why is it complaining? Cannot convert from double to float. It doesn't like that. We'll leave that double for now. You can hold single characters. A char letter equals a. A literal character has single quotes around it. A text, or what we call a string, has double quotes around it. The single quotes can only have one character in there. You can't have like A, B kind of thing. It only holds one letter. Okay, that's the important thing there. And there's a type called Boolean. It's not done yet. Give me a second. I'll just call value equals true. And this basically holds either true or false values. That's a comment at the end. So later when we get into like logical kind of things, you can make decisions based on Boolean values. Is this thing true or is this thing false? There's another kind of type. So these are all called primitive types. They hold sort of direct values, simple kind of values. Java variables can also be reference types. And there's an example. A reference type is a string. So we were looking at literal strings before, but I can assign them to a variable by giving the type name string, the name of the variable, and then whatever I want to store in there. These are called reference variables too, because we no longer sort of directly hold this this value. Instead, somewhere we store the location of where that text is in the computer. So this reference is telling me where this thing is. And we'll get in a lot more detail about this. It's a very important concept in Java. Okay, so why use variables? Well, here's three different ways of representing sort of the same thing. I can say tax due equals income times tax rate. I can say memory location 10,040 equals memory location 1028 times memory location 1036. And I can say x equals 45,000 times 0.331. These all basically end up within your computer memory at what's called an address. So each location in your computer memory has a number that says like this is location 1, 2, 3, 4 kind of thing. But you know, if you were to write code that looked like this M1 here, you wouldn't know what you were multiplying together, right? And in fact, it'd be easy to make a mistake. And if you came back later, it'd be hard to remember why you were doing it that way. When you give them these names, so tax due equals income times tax rate, it kind of makes clear what you were trying to do with that math, right? Somewhere there's a value that holds an income value, somewhere there's a tax rate value, and together that gives you how much tax you have to pay. So variables basically allow you to give little descriptions as to what's going on in an expression like this. Now, these variables are one example. It's called an identifier, and a variable name must have at least one character. The first character must be a letter, the underscore, or $sign, and pretty much just use a letter for now. And it can't replicate an existing keyword. Like if you try to use main as a variable, it won't let you do it because it knows that's where we start looking for running our program. You can't use int. You can't say like int equals 1 because int is used as a type. You want to make names that are meaningful for the problem you're solving. So really short ones like Q doesn't really mean anything. Use a variable name like cost or cost of, house or something like that. Don't get too long with it. It's sort of painful to try to read a super long name. This is the variable that holds the cost of a house, is way too long. But don't just say Q. Use something short, sweet, but that makes sense for other people and yourself. And don't make variable names that are actually actively wrong. I've seen, for example, people use a variable name row when they're really referring to where something is, they use the variable row, but they're referring to the column position in a grid. So it's like actively confusing what that person was trying to say there. And it's really easy to make mistakes with that. So be careful. So how do you use variables? You have to declare a variable before you use it. That's not true in some languages. So like Python, you can just start throwing variables in there and just as long as it has a value, it can be used. But we have to say, in Java, we have to say what type the variable is, right? This variable holds ints. Another variable might hold doubles. You have to give it a type. You're allowed to declare it and initialize it all in one line, which is what we were doing up here in our program. So I'm saying this variable, game lives left, is an int. It holds, whole number kind of things. And it starts off with a value of 3. Notice there's a semicolon at the end of each of those lines there. Oops. You can then use a variable any place you would use a literal. So when it says system out print line tax due, what would come out from that? It would say, well, what value is stored in tax due? $10,000 or something like that, right? And it would use that value to get printed out. It wouldn't print out the word tax due. It would print out the value that's stored here in this variable. Once you've declared a variable, you can just assign a value to a variable. So here, tax due equals. We use equals means take the value of the thing on the right and store it in the variable on the left. We will talk in more detail about assignment next class. So you can kind of think of a variable, some sort of named box, some sort of storage, right? And when I say put this value in age, it looks for a box with the age label on it, and it puts the value in there. And you say what value is in age, it looks for the box called age, sees what value is stored in there, and allows you to use that value in some other expression, some computation. So we already mentioned a little bit that you can give a variable a value. That's called assignment. And the destination is on the left, the value is on the right. And you can do that over and over again and replace the old value with a new value. A lot of people, or I don't say a lot of people, it's common to kind of get confused about how assignment works. You might try to write something like 15 is assigned number. That's backwards. It's called assignment dyslexia. So the destination is on the left, the value is on the right. All right, and you just have to keep that kind of clear. You also can't, it's not really like algebra going on here. It really says evaluate the thing on the right and put in the thing on the left. So it doesn't try to like balance this equation or anything like that. It has to be just the variable on the left and the full computation on the right. So we've sort of mentioned this a little bit, but there's expressions compute values, and so we don't have to have just literals in here. We can do math expressions, right? So I can say, for example, up here we have an expression. So we have math operators. In Java, we use the asterisks for times. Fortunately, divide is pretty normal. Plus is normal. Minus is normal. And there's some order to them. So in elementary school, we learn about the order of operations. So, for example, you do math before you do, you do multiplication before you do addition. And so you have to look at the expression and figure out the order of what's going on here. You can use parentheses to force some part of the expression to go first. You should be aware, let me get rid of some stuff here and do some print stuff first. Okay, so let me get rid of all that stuff. And let me make a more simple expression here. So if I have 20 divided by 10, and I run this, I made that way too small. Okay, we get 2 out. 20 divided by 10 is 2, right? What is 25 divided by 10? Now this is where Java is a little different from our human intuition. If I run this, I still get 2. The reason is that if this is an integer and this is an integer, then the answer is going to be an integer. And the integer doesn't hold that fractional part. So even though we know that the answer to this is 2.5, the 0.5 is lost. And we only get a 2 out of this. Okay, so it's pretty easy to make this mistake doing some computations where you really want some kind of more accurate answer, but instead you lose the precision because you're in integer land. One way to stop that is you can just add 0.0 to this, then this now is a double, this is an integer, and it picks the more general one of those. And doubles hold more stuff than integers, and so the answer will be a double in this case. And if I run it, I get 2.5 out. Okay, so be careful with that. I want to show one other thing I think I meant to do earlier when we were talking about types. So what is 2.0 minus 1.9? Well, if we do that in our heads, we know the answer is 0.1. 0.1, yeah. If I run this, look at this. I get 0.1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and then a 9 at the end. So what's going on here? Well, it's important eventually, again, this can cause problems. For the most part, that's just a small error that, you know, even in complicated computations, it won't really show up that much. But these literals get translated when they're stored in the computer from 2.0 into somewhat what's called binary representation, which the computer uses. And it can't represent some of these numbers exactly. Kind of like when we have 1 divided by 3, we can't really represent it exactly because it's 0.3333333 forever, infinity. Same kind of thing here happens in binary. And so we lose a little bit of precision with some kinds of numbers, and we get a little slightly different answers. We'll spend a little more time on binary at a future time. All right, so expressions. So we can use these variables in expressions, right? So I could have double value 1 equals 2.0, and I would use that. Value 1 is not a really great name, but I don't have any particular meaning to this thing. It's just a sort of nonsense thing. So when I use value 1 here, what happens? Well, it says what value is stored in value 1, and 2.0 is stored in value 1. And then it does the expression. It says 2.0 minus 1.9. And we get out our somewhat crazily incorrect answer. All right, so any place you make a variable, you can both put values in, and you can get values out of the expression. And in a similar way, it's not really any different, but if I make a variable count 1, I could say count equals count plus 1 and update that value that's in here, right? So how does this work? First, we evaluate this expression over here. So what was stored in count? 1 is stored in count. 1 plus 1 is 2, and then that 2 is stored back in the variable. And if I print out, let me just steal that. If I print out what's stored in count, I get that new updated value 2. All right, so this looks weird from, like, those of you who are math people, you know, if that was algebra, you can't say that's impossible, right? You can't say that the thing on the left is equal to the thing on the right. But we say, no, assign this value to this value and update it. These are all examples of Java statements. So this is a statement that produces some output. This is a statement that initializes a variable count. This is an assignment statement that updates a variable. And this is now the same statement that outputs a value. So an expression computes a value of some kind. A statement tells the computer to do something, right? Give this value, store it. Update this thing, print it out. So let's try to use some variables in what that original tip program was. It's now kind of gone. I'm going to, let me get rid of that comment as well. So I'm going to declare and initialize some variables, double meal cost, I'll call it, a little different from the code I have down there, equals some enormous value. Can't quite imagine spending $600 on a meal, but okay. And I'm going to have double tip percent equals, well, if I'm spending a big meal, I better at least hit 20% of my tip. And then I'm going to do a comment, calculate the tip, and I'm going to make a variable to hold that answer. Tip amount equals the meal cost times the tip percent divided by 100. And then I'm going to print out the tip amount. Let me get rid of that. Get rid of all the extra white space. That's bad. I'm okay having a little white space here. Kind of here we're setting things up, and now there's like a little new thing going on here where I'm doing some action, right? So what are we doing here again? We declare two variables, meal cost and tip percent, both of type double, and both assigned initial values. And then I declare a new variable and assign it the result of computing what the tip should be based on that math we were doing earlier. Before we just had literals in here. And then I'm going to print out that answer here. So I run it and I get, $100 for my server, pretty good. But I'd just like to point out the two things. Before we just had a bunch of numbers in here and printed it out. Again, you come back in a week, you wouldn't know what those numbers were. Why was I doing this, right? Maybe you have a comment, maybe you don't. Here at least, there are some names associated with this that make it a little more clear as to what's going on, right? So these variables are used to kind of guide you through when you read the code as to what is actually happening in this process. I'm storing some values in these named locations. I have an expression that actually makes some sense now because I can look at those names and figure out that matches what I think it should be happening. And then I print something out and I know what that is there. So I think this is a much better program than just those literals stuck in there from before. Okay, that's enough for now. Thanks.